Hi, this is Jason with Liquid Instruments. This is the second video in a three-part series about encoding, converting, and decoding digital data using different instruments available on the Moku device. In part 1, we encoded digital data using the Moku pattern generator, which you can see displayed on the oscilloscope right now. Today we're going to use the waveform generator instrument to implement analog modulation via amplitude-shift keying. We're still going to be working in multi-instrument mode, so we'll return to the system build screen. We're going to keep the Logic Analyzer in slot 1, and we're going to replace the oscilloscope in slot 2 with the waveform generator. Now for this demonstration, we will need a second Moku Go and a physical connection between the two of them in order to view the output. So we'll set that up later. We do, however, need to make sure that the output from the waveform generator goes to the analog front end. Click Apply Changes, and wait for the FPGA to configure. We're going to open the configuration window for the waveform generator. The first thing we want to do is enable the output and set it to a sine wave, and set our carrier frequency to 10 megahertz, and our peak-to-peak amplitude to be 5 volts. Now we want to add some modulation in order to turn our digital data into an analog output. There are a few ways to do this. We have techniques such as ASK, PSK, and FSK, which stand for amplitude, phase, and frequency shift keying. We can perform all three of these with the waveform generator, but we'll show ASK this time since it's the easiest to verify visually using the oscilloscope. Click on the Modulation tab and change it to Amplitude Modulation. We want to set the source to input A, so the amplitude of the carrier wave is being modulated by the voltage of the pulses from the Logic Analyzer. Let's set the modulation depth now. The exact value you will need for this will depend on how sensitive you want your ASK resolution to be. So let's set it at 40%, and that will allow us to see all three voltage levels pretty clearly. We're going to look at the transmitted analog signal using another Moku Go. In my setup, I have two Moku Go that are physically connected by a BNC cable. If I click on the plus icon in the top left, I can open another window where I see both of my instruments. We've been using the one on the left for signal production, so now let's look at the one on the right. Click on it, and we'll use the oscilloscope in single instrument mode for now. Wait a second for it to configure. We're only going to look at channel A in this case. If you zoom out to about a 150 nanosecond window, and set the trigger level to where the highest signal is, you can clearly see there are three different bit values that we programmed into the pulse sequence. You can revisit the first video if you want to see those again. The last thing we'll quickly do is zoom in, and if you click over to our measurement tab, you can see that we do indeed have a 10 megahertz carrier signal that is being amplitude modulated. That's it for today. In the final episode of this series, we'll show how to demodulate and recover the original data using the lock-in amplifier. Thanks.